Hello, class, and welcome to Module 4. We'll be working on 4.1a lesson today, which is introducing the idea of a system of linear equations. When we find the solution to a system of equations, we are basically finding the point of intersection, or when both of the equations have the same x and the y value. That will satisfy pretty much both situations. So let's go ahead and start by reading this first paragraph. The student council is planning a bake sale to raise money for a local food pantry. Students are going to be making apple and peach pies. They have decided to make 10 pies, and each pie requires 2 pounds of fruit. Therefore, they need a total of 20 pounds of fruit. Let's go ahead and underline that. 20 total pounds of fruit. 1 pound of apples cost $2, and 1 pound of peaches cost $1. Okay. So we kind of talked about this in a previous lesson when we talked about I think it was the granola bars or candy bar example, right? Where you have different combinations that you can have for your kind of situation. And it really depends on really how much money you're willing to spend on the pies that you're going to make. So again, apples cost $2 per pound and peaches cost $1. Okay, so if I were to buy 8 pounds of apples, and I need a total of 20 pounds of fruit, then I would need 12 pounds of peaches, right? Cost of apples would be 2 times 8, which is 16. Cost of peaches would be 1 times 12, which is literally 12. In this combination, I would be getting a total cost of $28, right? And you realize that you can make a various amount of combinations. Like if you look at the second example, 5 pounds of peaches would mean I would need 15 total pounds of apples, and the cost would be 2 times 15, which is 30, and 1 times 5, which is 5, for a total cost of 35. And then we're kind of going backwards now. If the cost of apples was 20 and each apple costs $2, that means I must have bought 10 pounds of apples, and then that also means I must have bought 10 pounds of peaches, right? 1 times 10 equaling 10, and this would equal $30 of total cost, right? Try to think of some combinations that you would create. Maybe let's do an extreme example of 20 total pounds of apples, 0 pounds of peaches. Not really an ideal situation because variety is important. But then I would get 2 times 20, which is $40 for my cost of apples, $0 for my cost of peaches, and then it would be $40 total, right? I could also do another extreme example, 0 pounds of apples, 20 pounds of peaches, right? 0 cost of apples. And then, 1 times 20 is equal to 20. And this would be the cheapest option, but also this would be the option with no apples, right? So let's do a final one. Let's do maybe a 12 pounds of apples and an 8 pounds of peaches combination. This would be 2 times 12, which is 24, and then 1 times 8, which is 8. This would also give me a grand total of $32. Okay, so this is just a list of different combinations. Of course, there are other variations. I didn't even use odd number for the number of pounds for each fruit, just to make it kind of clean. But let's go to the next part. Mrs. Harper, the student council advisor, tells the students they have exactly $28 to spend on fruit. How many pounds of each type of fruit should they buy so that they have the required 20 pounds of fruit and spend exactly $28? Okay, so it's basically giving us another constraint, right, class? Now we have a budget. We actually have to get 20 pounds of fruit, and we only have $28 to spend. Um, you can say, hey, I could buy 14 pounds of apples with that. But if you buy 14 pounds of apples, you won't have the 20 total pounds of fruit that you need for the first constraint, for the first kind of uh, restriction or necessity, right? And what's interesting enough, class, is the combination that would give us a $28 cost with 20 pounds of fruit is actually the very first row, right? We all see how this gives us 20 pounds of fruit at a cost of $28, right? So you would say 8 pounds of apples and 12 pounds of peaches. That would give us 20 total pounds. Okay, so here comes the part where we actually create the system, right? If X represents the number of pounds of apples purchased and Y represents the number of pounds of peaches purchased, write two linear equations in standard form, one of the most important forms in this entire module, standard form, that represent the situation. Explain in words what each equation represents in the context. Okay, so the key here is understanding that X represents apples and Y represents peaches. Okay, so I think the first equation that comes to mind is going to be the total amount of pounds that we need. X plus Y is equal to 20, right? This represents the total number of pounds needed in the context. Right, X plus Y is equal to 20. That satisfies one of the kind of contextual constraints, right? One of the things that we need to satisfy. The other one is about price, right? So apples cost $2, so I'm going to put the 2 in front of each apple. Peaches cost $1. I could put a 1, but I don't really need to do that. And the total budget that we have, according to Mrs. Harper, is 28. Right? This represents the cost or slash budget we need to maintain, needed to maintain. Okay, we need to make sure we don't spend more than 28. Now, it's also funny how it says you have to spend exactly 28. Cost budget needed to maintain, or budget that needs to be satisfied. Okay, does this solution you found in part B make both equations true, right? So does the combination of 8 comma 12, right, 8 being the apples, 12 being the peaches, does it satisfy both equations? 8 plus 12 is equal to 20, so that works. 2 times 8 is 16. 16 plus 12 is equal to 28. So yes, it does satisfy the system, right? We'd say yes, 8 comma 12 does in fact satisfy both equations. So we pretty much, we solved the system kind of by just looking at certain combinations. But you can also solve the system just by graphing both of these equations on a graph. So that's what we're going to do next, right? So if we have a graph given, and you can see that this graph is properly labeled, it's nicely labeled with number of pounds of apples on the x-axis, the number of pounds of peaches on the y. It's really nice. Always make sure you label your axes. Um, and let's go ahead and just write down both equations again. Now I'm going to write both of them in standard form, but remember that slope-intercept form is also a nice format when graphing, right? 2x plus y is equal to 28, okay? I'm going to color code this. Let's go ahead and make green the first one, and let's make orange the second one, so we know that where two lines are. Now, when x plus y is equal to 20, class, doesn't that mean that I can technically just kind of solve for the x-intercept and the y-intercept, respectively, right? The x-intercept, I can have 20 total apples if I want, and 0 peaches. Or I can also have 20 peaches and 0 apples, right? So right away, I have 2 points on my line, and I know that I can just connect my line like that. Okay. Now you can't really see that this is green, but that's okay. And now I'm going to go ahead and graph the second equation using the x-intercept and the y-intercept route, right? If I were to block out the y, I get 2x is equal to 28, which gives me a grand total of 14. 14 apples total. That would be the most amount of money I can spend because remember, 28 represents the budget. I could also buy 28 peaches, 28 pounds of peaches, but also realizing that we only need 20. You kind of don't want to buy extra because then Mrs. Harper will get mad at you and ask, why did you buy, 8 extra pounds of peaches when we only need 20? And you could see that there's an intersection point, right, class? Where is the intersection point for both equations? It's literally at the combination that we said it was supposed to be at. Right there, right? 8, 12, right? Is that a coincidence? Is that something that we're surprised about, right? This is the total cost line, and this is the green is going to be the total pounds line or equation, right? The point of intersection is 8, 12. Is 8, 12, which is the same, which is the solution that we solved for in part B. Okay, not too bad, right, class? So the bake sale problem can be modeled and solved using a system of linear equations. Write in your own words what a system of linear equations is. Explain what the solution to a system of linear equations is. How can you find the solution in a graph, right? I want you to write what you think a system of linear equations is. I think one of the easiest ways to explain it is a system is a set of equations that represent a given situation, right? Notice how it has to be more than one equation, right? One equation represents one kind of aspect of the situation. Another equation represents, another part of the situation. They're kind of related, but they're not exactly the same exact equation. And when you find the point of intersection, the solution to the system is the point of intersection. That satisfies all equations in the system, right? It's where the combination that is perfectly making either the first equation, the second equation. You'll learn later that there can be more than two, but right now we're only working on two. But the point of intersection is the value for x and y that will satisfy both equations. It will make both equations true, and it's pretty much the answer to your system. Okay. Now, one thing to remember is that sometimes systems don't have a solution, right? Sometimes a pair of lines may not intersect. And if that's the case, then there is no solution. But let's just keep it at the idea of that there is one. Okay. This is the introduction to a system of linear equations. There will be two more practice problems, but let's go ahead and try that in class. Thanks for watching.